Hey guys, and welcome to your 10.5 notes. So 10.5 is all about angle relationships inside of circles. And the first one that we're going to talk about is our tangent and intersected chord theorem. So back to 10.1, we learned about what those pieces of the circles were. So we have our tangent on the outside here, and we also have the chord that cuts through the circle. Okay, so this theorem says if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So what that means is the measure of angle 1 in this picture would be 1/2 of arc AB. Okay, so see those are color coordinated there. That's 1/2 of that arc. And the measure of angle 2 would be 1/2 of arc ACB. That's my major angle or arc on the other side. So for our first couple examples, we have line M is tangent to the circle. So in both of these pictures, line M is my tangent, and I want to find the measure of the red angle or arc. So in the first one, I'm trying to figure out what this angle measurement is. Okay, so that angle measurement, remember, is 1/2 of my arc. So 1/2 of arc AB is going to get me my measure of angle 1. So since I know that is 130 degrees there, I'm going to take half of that. So the measure of angle 1 is 65 degrees. Okay, for the second picture, I'm trying to figure out what the arc is. So you're working backwards. So 1/2 of the arc equals the angle. Okay, this time you know the angle is 125. And you're trying to find the measure of my arc. Okay, so I'm going to work backwards, so I'm going to multiply by 2 on both sides. So the measure of arc LJK is 250 degrees. So what we're going to talk about moving forward are actually what happens if we have two lines that cut through the circle. Okay, so before we had a tangent and one chord, now we have two intersecting lines. So if two non-parallel lines intersect at a circle, there are three different places where the lines can intersect. So they can intersect on the circle, inside the circle, or outside the circle. And depending on where they intersect is what we actually have to set the problem up as. So for example, the first one that we're going to look at is where they intersect inside the circle. So if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by that angle and its vertical angle. Okay, so I'm going to write that into a formula here. So for example, angle 1 in our picture is equal to 1/2 of arc DC plus arc AB. Okay. So these are both arcs here, okay? And those, notice, kind of make like a bow tie shape. So you want the arcs that are part of that bow tie shape to make the angle that's on the inside of the bow tie. Notice how angle 2 is on the outside of the bow tie. So I know angle 1 plus angle 2 are supplementary because they form a linear pair. So if I find out what angle 1 is, I can find out what angle 2 is by taking that away from 180. Hey, the next part that we're going to talk about is what happens if they intersect outside of the circle. So if a tangent and a secant, two tangents, or two secants intersect outside of a circle, then the measure of the angles formed is 1/2 the difference of the measures of the intercepted arcs. Okay, so for example, I'm going to use this first picture here. The measure of angle 1 is 1/2 of the difference of the arcs. And we're going to take the outside arc minus the inside arc. So notice what I'm saying by outside versus my inside. Okay, so we want the bigger arc minus the smaller arc because we don't want to end up with a negative angle measurement. So big minus small. Okay, so here's an example, one of each of those types, and we're going to find the value of x. So for this one, here is my bow tie shape. Okay, this one's a fat bow tie this time, so I'm looking at these arcs that go with that angle of x. So remember, your angle is equal to 1/2 of the sum because they intersect inside. Okay, so inside is the sum of those two arcs. So I'm going to add those two together, and then I'm going to take 1/2 of that. So I get the x equals 143. Okay, for my next one, they intersect outside. So this one is the difference, which means I'm subtracting. So I'm going to have x, that's my angle, is equal to 1/2 of my big arc minus my small arc. Remember, you don't want a negative angle to come out here, so big minus small. And then take 1/2, so I end up with x equals 51. Okay, a couple more examples, another one of each type. So on this one, I noticed here are my arcs for my bow tie. Okay, but I don't have these angles. Remember, those are the angles that go with the bow tie and those arcs on the outside. So what I need to do is actually use this extra information that's out here in order to find one of those angles. So remember that those angles form a linear pair. So it doesn't matter which one you choose because either way it's going to be a linear pair. So what I'm going to do is I'm going to take 180 minus 102, and I'm going to figure out that that is 78 degrees. So when I'm looking inside my bow ties, I know that's 78 degrees. Okay, so once I set up my problem, remember the angle goes on the outside, or set what is set equal to. So your angle is 78, that's equal to 1/2 of your arcs added together, because this is an intersection inside. So I'm going to have 95 plus y, because that's what my other arc is. So what I'm doing in this one is actually solving for one of the arc measurements. So I have 78 equals 1/2 of 95 plus 1/2 y. Okay, now if you're someone that right away wants to get rid of that 1/2, you could have multiplied everything by 2, but it doesn't matter at this point. So we're going to take that 78 and subtract our 47.5 over. So we get 30.5 equals 1/2 y. And then here I'm going to multiply by 2 at this point to get rid of my 1/2. So I get y equals 61. Okay, and if you multiplied by 2 at the beginning, you should end up with the same answer at the end, 61. Okay, for my next problem, this one is an intersection outside, so I'm thinking in my head, I know this is subtraction. I know my angle should equal 1/2 of my big arc minus my small arc. So this is like a little bit of a format that I'm filling in the blanks each time. So my angle is 30 degrees. Okay, then I have 2 more blanks over here. Remember, it's a big arc, which is the one on the outside, minus the small arc, which is the one on the inside. Okay, then this time, remember, again, you could multiply by 2 right away if you wanted to. So I end up with 60 equals a minus 44. And then I'm going to add that 44 over to the other side. And I get that a is 104. Okay. If you distributed the 1/2, you should end up with the same answer in the end. A equals 104. The last thing that we're going to talk about in 10.5 is circumscribed angles. So those are angles whose sides are tangent to the circle, meaning they only touch in one place. Okay. So we've seen a few of these so far, but we haven't figured anything out about how to solve them until this picture. Okay, so the measure of the circumscribed angle is equal to 180 minus the measure of the central angle and the arc that intercepts that same angle. Okay, so I'm talking about this formula down here at the bottom. So your angle is equal to 180 minus a central angle. Okay, and that central angle, remember, could be the same as this right here. This arc could be the same as your central angle. Those are the same, so it depends on which one it gives you as to which number you would use. Okay, so last two examples here. One of the circumscribed angles, that's our first example. It looks like we have our angle equal to 180 minus that central angle, is what they gave us, so 135. So this one's pretty short here, so my angle X is 45 degrees. And the last one, I'm finding the measure of angle T. I noticed that these are actually cutting through my circle instead of tangents on the outside. So this is where my angle is 1/2 of my arc minus my arc. So I know my angle is X divided by 2. Then I have 1/2 times the outside arc, that's X plus 70, minus the inside arc. Notice I put another set of parentheses right there. Okay, because it is minus minus. So we want to make sure we distribute both of those. So you could write it as minus X minus 30, okay? And we can get rid of that 2 as well, okay? So I could multiply by 2 in order to get rid of the 1/2 and to get rid of the 2 from the other side. So I end up with X equals, and right here I have X plus 70 minus X minus 30. So my X's are going to cancel, okay? And I end up with X equals 40 as my final answer. Now your homework is on Clever. Make sure you're asking any questions if you have them, email or through Teams. That way, when it comes to your test next week, you guys are good to go.